Hi, welcome to the AVM Math Hub. Today I am discussing about CSR mathematical problems on previous question papers. Let us see the first problem. If L is equal to limit n tends to infinity 1 by nth root n factorial, then options 1, L is equal to 0, second option L is equal to 1, third option L lies between 0 to infinity, and fourth option L is equal to infinity. What is the given statement? By using the given statement, we can solve the options. Given that, first write the given statement. L is equal to limit n tends to infinity 1 by nth root n factorial. Now this can be written as limit n tends to infinity 1 by nth n factorial whole power 1 by n. Nth root means whole power 1 by n. Also, this can be written as limit n tends to infinity an. Let us assume that this statement, this condition, let us assume that this is an. So an whole power of n. So this is in the form of Cauchy's second theorem on limits. Since Cauchy's second theorem on limits, if limit n tends to infinity an whole power of 1 by n is equal to L. Also, first write the statement, limit n tends to infinity an is equal to an whole power n, an whole power 1 by n is equal to limit n tends to infinity an plus 1 by an. So this is the direct consequence of Cauchy's second theorem on limits. So here an is equal to 1 by n factorial. Okay. Now the given statement L is equal to limit n tends to infinity an plus 1 by an is equal to limit n tends to infinity. What is an plus 1 means? An is equal to 1 by n factorial. So what is an plus 1? 1 by n plus 1 factorial. 1 by n plus 1 factorial divided by an. What is an? 1 by n factorial. Now we can write in multiplication. Division of two fractions is not possible. We convert into multiplication. Now this can be written as n factorial. That is equal to limit n tends to infinity. Here we can write in the n factorial notation. N factorial is equal to n plus 1 into n factorial. That is equal to 1 by n plus 1 into n factorial into n factorial. These two are cancelled. That is equal to, so limit n tends to infinity 1 by n plus 1. So that is, this is converges to 0. Therefore, hence capital L is equal to 0. So this is converges to 0. So what is L0? So first option is the right answer. And one more problem. Consider the sequence an is equal to 1 plus minus 1 whole power n upon n whole power n. Then the first option, limit n tends to infinity supremum an is equal to limit n tends to infinity infimum an, both are equals to 1. The second option, limit supremum n an is equal to limit n tends to infinity infimum an, both are equals to e. Limit n tends to infinity supremum an, limit n tends to infinity infimum an is equal to 1 by e. And limit n tends to infinity supremum an is equal to e, limit n tends to infinity infimum of an is equal to 1 by e. So by using the given statements, I will prove the given condition. First write the given statement. Let an is equal to 1 plus minus 1 whole power of n into 1 by n whole power n. So here this is minus 1 whole power n, minus 1 whole power n. Whenever in the given statement -1 whole power of n is there, then we can write the statement split into two parts. If n is even and n is odd. Suppose if n is even, then what about an? An is equal to, so -1 whole power of n means the positive term. When if n is even, so this can be written as 1 plus 1 by n whole power n. If n is odd, then an is equal to 1 minus 1 by n whole power of n. Now the sequence an is equal to, so first one is e if n is even. So that is 1 plus 1 by n whole power of n means the value of 1 plus 1 by n whole power of n is equal to e. Already we know the condition of this one. 1 plus 1 by n whole power of n is equal to e. Similarly, 1 minus 1 by n whole power of n is equal to 1 upon e if n is odd. So the limit points of sequence n is 1 is e and 1 by e is the another limit point. Now so we can write in the one set, the set of all limit points. Let capital S is equal to e comma 1 by e, the set of all limit points. You can write one at one in the given set. Here limit here e comma 1 by e, this is the upper bound and this is the lower bound. This is the supremum and this is the infimum. E is the supremum value. Limit supremum value is equal to e and the limit infimum value is equal to 1 by e. So the option limit n tends to infinity supremum an is equal to e, infimum value 1 by e. So option 4 is the right answer. For a comma b belongs to n, consider the sequence dn is equal to na upon nb. For n greater than a comma b, which of the following statements are true? The first option, sequence dn converges for all values of a and b. Second option, sequence dn converges if a less than b. Third option, sequence dn converges if a is equal to b. Fourth option, sequence dn converges if a greater than b. A greater than b. We can solve the given statement and the given sequence by using the given options. First of all, sequence first write the given statement. Given that dn sequence n a upon n b can be. Write the full form of this one. So ncr factorial. So n factorial by a factorial into n minus a factorial into, similarly we can write this n factorial divided by n factorial by b factorial into n minus b factorial, NCR formula. So n factorial cancel. That implies dn is equal to, write the given the remaining b factorial into n minus b factorial by a factorial into n minus a factorial. So let us assume that this is equation 1. The case 1, suppose we can take, a is equal to 2, b is equal to 1, and that is a greater than b. The option is fourth option. If a greater than b in case 1, I will take a greater than b. That is dn is equal to n minus 1 factorial by a is 2 means 2 into 2 factorial means 2 and n minus 2 factorial. So n minus 2 factorial, that is equal to So n minus 2 factorial means n minus 1 factorial means by using n factorial definition, n minus 1 into n minus 2 factorial. So finally n minus 1 divided by 2. So we can apply limit n tends to infinity, n is equal to n minus 1 by 2 factorial means it is diverges to plus infinity. So not convergent. Not convergent. So sequence DNA is converges if A greater than B. See, if A greater than B, the given sequence is not convergent. So this is wrong. This option is wrong. And case 2, if A less than B. If A less than B means that implies we can multiply with the minus and we can add minus A greater than n minus B. We can write like this, less than n minus A. N minus B is less than n minus A. Now, what is dn? What is dn? dn is equal to now dn is equal to b factorial. bn is equal to b factorial n minus b factorial into n minus b factorial and a factorial n minus a factorial. N minus a factorial. So this is b. That is equal to b factorial into n minus b factorial by a factorial into, by using the factorial notation, we can write like this, n minus a into n minus a minus 1, n minus a minus 1, and so on. For n minus a factorial, I can apply the factorial notation only for this. So finally, n minus b plus 1 into n minus b. N minus b factorial. Finally. So n minus b factorial and n minus b factorial. So factorial b by something. Factorial b by something means this is converges to 0 as n tends to infinity. So because n into n into n into like this, so this is converges to 0 as n tends to infinity. When therefore when a less than b, the given series dn is convergent. Okay. And the case 3, the third option, a less than b. If a less than b, it is convergent. So second option is right. And third option, a is equal to b. Case 3, if a is equal to b. If a is equal to b, then the sequence dn is equal to a is equal to b. Means both are cancelled, a by a or b by a. So that is equal to 1. That is equal to 1, comma, for all n which is convergent, which is convergent, because being it is a constant sequence, being it is a constant sequence, it is a constant sequence. So in case 3, a is equal to b also converges. So option 2 and option 3 are right answers. Okay. So this is the way we have to solve any problem. By using the given options, we can solve the given problem. If you have any doubts, please WhatsApp me. I will respond immediately. Thank you so much. Have a nice day.